Okay, we're going to look at orbital notation versus electron configuration notation versus noble gas notation, so you can make sure that you know which one you're doing when you're asked. Okay, so we'll just pick an element somewhere near the top of the periodic table, so we don't have to go too terribly far, as we're just talking about the types and not actually doing a whole lot of notation ourselves. So if we go to the periodic table, let's look at calcium. So we're going to pick calcium, and if we look here on this periodic table, it should show us the electron configuration here underneath atomic properties, but we're going to figure out how we got there. So calcium, if we draw just the top part of the periodic table, is right here in group 2, period 4. So if we look at the periodic table and we know that our electron configuration, every time we go further to the right or further down on the periodic table, we're adding electrons in our configuration. Our electrons fill into the next available space. Remember that we need to fill subshells completely before we move to the next subshell. But in each subshell, the orbital that's in that subshell, we are going to fill one at a time until any of them have 2. So, we are also going to make sure that we stay in our order. So you're always going to start with 1s. And if we were looking at just hydrogen or helium, that's as far as we would go. But we're going all the way to calcium, so we're going to go past it. So the electron configuration of calcium is going to start with 1s2, because we're going to have both electrons there. After the 1s, here I'm going to mark off these placeholders for the electrons as we go. So after the 1s, now we're here to the 2s orbital. So calcium's well past that, so we're also going to use those two. Then so we get a 2 here. Then we have 2p, which is over here in this area, and we're still well past that as well. So we get 2p6. And then down to 3s, and it's completely full. 3p, which is also completely full. And finally, we are into the block where calcium exists. Now, calcium is the second element in this block, so we are going to have a completely full subshell, a full S subshell, and it will be 4s2. Now, if we were going to write the same configuration as noble, or not as noble gas, as orbital notation, orbital notation also shows not only the principal energy level, which we would have showing here as the 1 or here as the 2, it also is going to show the orbital shape, which is our S. It shows how many electrons we have and their spin. So it's going to take in all 4 quantum numbers. So we start, it's going to go in the exact same order. We got 1s. 1s is full, so it's got electrons spinning in opposite directions. Then we have 2s, which is full, electrons spinning in opposite directions. 2p. Now, this fills, each orbital gets 1 electron before any gets 2, but since this is a full one, they're all going to be completely full with electrons spinning opposite of one another. Then we have 3s, 3p, again it's full so I can fill them all, and 4s, which is also full. So that would be the orbital notation for calcium. Now, the notation we all like to do is noble gas notation, because it's faster. Why do I keep writing an A for the second letter of notation? So the way you do that is you go back to the last noble gas you passed, which is going to have a P6 configuration. So in this case, it would be here, as we have 3p6, and we condense all of that into whatever noble gas that is equivalent to. So if we look at our periodic table and we find the one that's in the 3rd group and all the way over on the far right hand side, we get argon, which if we scroll down we'll see that argon's configuration here in atomic properties ends with 3p6. So we, instead of writing all of, here, let's highlight it, all of this here, we are going to fast forward and write that like this. That means that we just wrote all that stuff that I highlighted, and then we will continue our configuration till we get to the element that we want, which in this case is calcium, which is 4s2. So if you were to be asked for electron configuration, you would want to give this, because that's how electron configuration is written. Orbital notation is written with the arrows, and noble gas notation has the noble gas and then your electron configuration after that noble gas until you have the configuration that you want to achieve.